How's it going, guys? So, I've been getting a lot of emails about questions on the trigonometry word problems. So, I decided I'm just going to make a video going over all 8 problems because they're going to be on your test next week. So, we're going to jump straight into it, you know? We still got to pray, though, because in the great words of Jesse Brooks, you gotta pray every day. In the name of the Father, Son, and Spirit, amen. Heavenly Father, as always, please pray for anybody watching this video, including myself. Please pray for everybody during the coronavirus and just during these difficult times, and just help us all grow in faith and virtue and just become a better version of ourselves each and every day. Working on ourselves first and then using that as fuel to help us help other people grow. So help us be open to growing closer to you and as a human being, and just treat everybody with love and respect as we're all one in Christ. So help us do that by interceding through your mother Mary, who said yes to giving birth to you over 2,000 years ago, by praying, "Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thy intercession was left unaided. Inspired with this confidence, I fly unto thee, O Virgin, my mother. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of thy Word incarnate, despise not our petitions, but in thy mercy hear and answer me." Amen. In the Father, Son, and Spirit, amen. Whoa. All right. So, let's get to it. Let's relocate. I will say, although I'm not wearing a jersey because this isn't actual class, this is just extra. I do, however, although I'm not wearing a jersey, I have a Cleveland Cavaliers jersey towel for my dry erase board. All right, that's enough, Mr. G. All right, so your homework. It was this worksheet, right? Word problems using right triangle trig. So I will go through these 8 problems, and then that's all we're doing. Notice I crossed off number 10. All right, so you have to do 1, 3, 4, 7, 8, 11, 12, and 15 is the challenge problem. All right. So I'm just going to read these one at a time. We're going to rock this out with some trig knowledge. All right. So without any further ado, number 1. A damsel is in distress and is being held captive in a tower. Her knight in shining armor is on the ground below with a ladder. All right, so let's draw a picture. A damsel is in distress and is being held at the top of the tower. So here's my tower. I'm just going to use a triangle, okay? Here's my tower. Her knight in shining armor is on the ground on the ground with a ladder. All right, so we're going to say K is the knight. Here's D for our damsel in distress. Her knight in shining armor is on the ground below with a ladder. Here's a ladder. Yep, that's our ladder, Daniel. Daniel had a great email of information on ladders. Anyway, when the knight stands 15 feet from the base of the tower, 15 feet, base. All right, so here our knight is 15 feet away from the base. Remember, base means bottom. So that's 9 degrees, because this is my tower, that this damsel is up here doing whatever, looking down at her knight. And it says the angle of elevation to her window is 60 degrees. Angle of elevation, right over here. All right, so how long does the ladder have to be? So our ladder is leaning up against the wall, right? It's not vertical. That's not safe, Daniel. So this is X. Okay, so maybe I did this wrong. I don't know. A damsel, where's 15? So when the knight stands 15 feet from the base of the tower and looks up, I think I had this wrong on the answer key. I went too fast, actually. So if you missed number 1, I believe you're probably right. So my apologies as I am slowing down. Now, I will say, this is a 30, 60, 90 triangle. So you could use your 30, 60, 90 degree shortcut if you made this 30. Because the side opposite 30 should be half the hypotenuse, so I'm already saying that the ladder should be 30 feet. But let's use trig, since that's what we're talking about. So the angle of elevation is 60, so how long does the ladder have to be? So here's my angle, opposite, hypotenuse, adjacent. All right, so we've got adjacent over hypotenuse. Hopefully you've been doing SOHCAHTOA. If that does not mean anything to you, it should. And if it does not, you're in big trouble on the test next week. Anyway, A and H, cosine. So we're going to have cosine of 60 degrees equals adjacent over hypotenuse. So that is 15 over x. Remember, if x is up high, you multiply. If it's down low, you divide. So we're going to switch these bad boys. We're going to do x equals 15 divided by cosine of 60. And I believe that should give us 30 feet. Let's see. 15 divided by cosine of 60. 30. So our final answer is x equals 30 feet. So I had that wrong on the Desmos. I'm sorry, guys. Man, throw me a bone. I'm delusional. I've missed you guys for so long. I make mistakes more often. I don't know. But anyway, that's number one. Let's see. Moving on. What was the next one, Mr. G? Number 3? Okay, number 3. Hopefully you have this worksheet out. A 12-meter flagpole cast a 9-meter shadow. So, 9-meter flagpole. Sorry, 12-meter flagpole. So that's 12. It casts a 9-meter shadow. Shadows are on the ground. Boom. 9. So if the shadow's behind it, that means the sun's somewhere over here. Okay. So find the angle of elevation to the sun. Let's form this triangle. That is x degrees. I got to find x. Label this as your opposite, and that's your adjacent. Should be getting better and better at this. So I'm just going to go straight to TOA. So we should have tangent of x equals 12 over 9. So you got to do the inverse tangent of 12 divided by 9. Second tangent of 12 divided by 9. 53.1 degrees is the angle of elevation from here to the sun. So there we go. That, ladies and gentlemen, is number 3. Moving right along. If I went too fast or you didn't see all my work before I erased, you can go back and watch the video and pause it if you'd like. Okay, number 4. Suppose you're flying a kite and it gets caught up in a tree. Here's my tree. Beautiful tree, Mr. G. My kite. You've let out all 100 feet of string of the kite. So here's this dude, whoever this is. He's flying his kite. There's his kite. He's let out 100 feet of string. So that is 100 feet on the hypotenuse. And let's draw this with a right triangle. Now this isn't to scale. I should have made it up on the ground, but it's okay. You let out all 100 feet of the string, and the angle that the string makes with the ground is 75 degrees. So evidently this dude who is flying a kite is lying on the ground for some reason. But instead of worrying about how you get your kite back, you wonder, how tall is that daggone tree? So this is x. Let's erase that. We don't need that. So that's the tree. That is x. So now I got to use which ratio? That's opposite and hypotenuse. So we're using sine for so. So your setup for number, what is this, number 4? Your setup for number 4 should be sine of 75 degrees equals x over 100. If x is up high, you know you got to multiply. So x equals 100 times sine of 75. And that is how I would type that in your calculator. I always type whatever number's on the right side in my calculator first. Then I worry about the trig junk later. All right, so 100 times sine of 75. And we've got 96.6. So that means this is 96.6 feet. That is a near 100-foot tree. and our kite is stuck in it. Doesn't that suck? Daggone kite. Oh, and I just broke my spray bottle. What's this world coming to? Oh, okay. There's number 4. What are we, halfway done by now, maybe, almost? I don't know what's going on anymore. I'm just at my apartment all day going crazy. Number 7. A fire department's longest ladder is 110 feet long, and the safety regulation states that they can use it for rescues up to 100 feet off the ground. All right, so we got a building. We'll say it's up to 100 feet off the ground. Oh, there's our building. So we got somebody stuck in a window or something. I don't know. I've never been a fireman. But the longest ladder is 110 feet long, just like before. Here's my ladder on the hypotenuse, right? That's 110 feet. So what's it say? What is the maximum safe angle of elevation for the rescue? So here's this, 9 degrees. Angle of elevation, that's right here, x degrees, and our job is to find that angle. So that's my angle, opposite, hypotenuse. So I'm using opposite over hypotenuse, which is sine. So I've got a sine of x equals 100 over 110. Hopefully I'm not going too fast with the SOHCAHTOA stuff, because we should be rock stars at that. If you don't get that, that means you need to go back and watch a couple class periods ago, because you are behind. If you understand everything that I'm doing, you're doing great. You do you, and I'll do me. Our answer, as we do inverse sine on that, should get an angle of 65.4 degrees, and worded more mathematically accurate is 64 or 65 and 4/10 degrees. So there we go, guys. That is number 7. Ho, 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 ho. One too many chocolate-covered coffee beans this morning, Mr. G. I like chocolate-covered coffee beans. Quit judging me. What's wrong with chocolate-covered coffee beans? Gosh, you can't knock it till you try it. Come on. Number 8. Number 8, the last one on the front page. This is a good one. Brothers Bob and Tom, cats, buy a tent that has a center pull 6.25 feet. So we got a tent. 6.25 feet. That's the center pull. All right, let me make that a little bit bigger, Mr. G. 6.25 feet. So 6 1/4 foot. We got a tent. So that's a center pull. So what's a tent look like? Boom. Boom. There's my tent. 9 degrees. The pole is stuck in the ground. Right? So that is 9 degrees. There's my pole. The center pole. If the sides of the tent are supposed to make a 50-degree angle with the ground. Side of my tent, ground, 50 degrees. 50 degrees. Okay? It's saying how wide is the tent, right? So how wide is it from here to there? So here's what you got to do, because a lot of you guys did this right. You just didn't double it, all right? Because if I just focus on this triangle, right, which is equivalent to this triangle, right? They're congruent triangles, all right? What do I need to do? I need to find this, all right? Because it's asking you how wide is the tent. So this is x. But so is this, right? But I'm just going to do this triangle. I only care about one at a time. All right, so that's 50 degrees. That is opposite. This is adjacent. So we've got TOA. We've got some TOA action. So we're going to have tangent of 50 degrees equals 6.25 over x. X is down low, so what do? We switch with the trig and we divide. So we've got x equals 6.25 divided by tangent of 50. If I type that in using my handy dandy calculator. Did you guys know that back in the day, they didn't have trig calculators? You had to know the trig ratios by yourself or by using a chart. Amazing. And you guys think math is hard in 2020. You don't even know. I took a history of math class back in the day in college. This is a breeze compared to what that class was. Anyway, 5.244 whatever. And that's the same thing with this, right? So you got to take this and add it with the same number on that side. Or you can just take that number and multiply it by 2. That's what I did. Right, so I just kept that number in my calculator like so, multiplied it by 2 because I only have half of it right now, and I need the whole thing. So times it by 2 and you will get roughly the whole thing as your final answer to be the 10.5 feet if I round to the nearest tenth. Okay, so that right there, ladies and gentlemen, is how you do number 8. Okay, hopefully this is making sense. I hope this is helping. We've got 2 more problems. 2 more problems. 3 more problems. Sorry, getting ahead of myself. I don't like this rag as good as my other one, but the other one needs to be in the laundry. This isn't erasing as well as I'd like. So we're doing number, what, 11? Oh, come on, Mr. G. Oh, and I just broke my board. What the world? What's this world coming to? Drop my calculator. I'm losing my mind, guys. Number 11. The tallest television transmitting tower in the world is in North Dakota. I'm trusting that that's true. And it is 2,059 feet tall. Here's my tower. 2,059 feet. If you are on level ground exactly 5,280 feet, 1 mile, which we should hopefully know. If you don't, now you do, and you should remember that. That should be common knowledge of how many feet are in a mile. So from the base of the tower, so it says, what is your angle of elevation looking up to the top of the tower? So here's the tower. That's the tower. You are standing over here, so you're looking up. Angle of elevation, once again, is right there. So you got to find the rate, or you got to set up your trigonometry equation. Opposite over adjacent, so we're using TOA. So we've got tangent of x degrees equals 2059 divided by 5,280. So you got to do inverse trig, or inverse tangent, and then just type that in. Second tangent, 2059 divided by 5,280. You'll get 21 and 3/10 degrees. Is that what I have on my answer key? Why, yes, I do. So that, ladies and gents, is number 11. The end is in sight. The end is in sight. There's got to be a better rag than this, Mr. G. Cleveland Cavaliers jersey towel isn't doing the best for me. It's making things sloppy. Number 12. What do we got going on with number 12? Ophelia Payne. Oh, I feel your pain. Very funny. Ophelia Payne is walking to her office building, which she knows is 150 feet high. All right, Ophelia Payne. She's walking to her building. Here's their building. I guess I can make it like a building. I don't know. Anyway, she's like, this is 150 feet high. Why does she know that? I don't know, because she's insane. The angle to the top of the building from her current location is 6 degrees. Wow. 6 degrees is a lot smaller than what this picture shows. But that's like very, very small angle. 6 degrees is probably like that small of a measure. But anyway, so this is not drawn to scale, clearly. So what's the question? How much further does she need to walk? Here's the ground, unless she's elevating like a crazy person. Maybe she's an angel, but she's walking on the ground. 9 degrees. Once again, we're using tangent, because that's my angle. Opposite over adjacent. Now, I will say, if I want to be extra, I can say that this angle is 84 degrees, because I know there's 180 degrees in a triangle. And I could say that's 84, and I could say that's opposite and that's adjacent. But Why would I do that? Why would I do extra work whenever I don't need to, Mr. G? Great question. Let's stop talking, Mr. G, and just continue with the problem. Okay. Jeez. So that's opposite. That's adjacent. Our problem is tangent of 6 degrees equals 150 over x. X is down low, so you divide. So I'm just going to type in 150 divided by tangent of 6. Should get a pretty big number. And you do, you get 1,427.2 feet. So that's how far she is away from the building. That is how much further Ophelia Payne has to walk to get to work. Now we've got our last problem, the challenge of the day, the best problem on the entire paper. Probably not, actually. There's some more challenging problems that I could have assigned you, but I'm a nice guy because I don't have you in class every day. So I only chose one of them. If you want a challenge, do some of the ones I told you to skip. Oh, okay. Why would we do that, Mr. G? We already have enough to do. I know. This is not erasing at all. Last time I'm using Cleveland. Okay, so the picture's the problem here. This is the hardest one to draw, okay? So a communications tower is built on top of a building, all right, with the following specifications. So a tower, so here's our building, and a tower is on top of the building. So we'll say that's our tower. Okay, so the building, we'll put our windows in there if you want to be extra, and this is our tower. Okay, it kind of looks like a cone head, I don't know. Anyway, from a point, I gotta reread it. A communications tower is built on top of a building with the following specifications. From a point 200 meters from the base of the building. So 200 meters from the base of the building. The angle of elevation to the top of the building is 23.6. Now that is those numbers. Now I said this in the email. I think it was in the email, but let me fill that in for the tower. Okay, but we got to switch those two numbers, okay, because it doesn't make sense. The angle of elevation to the top of the building, so this angle to the top of the building, that's where the 15.9 degrees goes with just that part, okay, because it's a smaller angle. And then the 23.6 should be the one that goes to the top of the tower. Okay, so this whole thing is the 23.6 degrees. Okay, so we've got this triangle, the smaller triangle, then we've got this angle is 23.6 degrees, the whole thing. Okay, so here's what you got to do with this problem, because the question says find the height of the tower. So here's the tower. Our goal is to find this. Okay, so I'm going to put a question mark there. All right. In fact, we'll just say that's x. That's what I'm trying to find. But to do this problem, you got to break it up into two triangles, right? Because you got 9 degrees right here. So you got this triangle. Maybe I'll grab another color. Brown, I guess, because brown is super pretty. So we've got the brown triangle. And then we've got this whole triangle in black. Okay, so I'm virtually doing two triangles here. So we'll just say this whole thing is y, and this whole thing is x. So we have to do two trig problems here, guys. Now, what do you think we got to do once we're done? You have to subtract this answer from this answer, and then you'll be able to get just the x. Oh, I'm sorry. I'm totally doing this wrong. This whole thing is y, and then this thing, the building, is x. Sorry about that. All right, so then you have to take this one and subtract it from the building to get this. So that's why I had the question mark there from the beginning. All right, hopefully that didn't stump you. So let's do this triangle. The building. So this was 15.9. Here's x. That's 200. All right, so our trig ratio, 15.9 opposite over adjacent, tangent. So we've got tangent of 15.9 equals x over 200. Opposite over adjacent. Now for the big triangle, we got 200 again, but then this time the angle is 23.6, right? So these are overlapping. And then this right here is my y, right? So for this triangle, we're still using tangent, but it's a different angle, and we're using y for the whole thing. So we're going to have tangent of 23.6 degrees equals y over 200. All right, so what you guys have to do is you need to do both of these problems, okay? And for the smaller triangle in brown, you should end up getting roughly, for the height of the building, you should end up getting 56.97 or something. And then for the whole thing with the y, whenever you use this one, you just multiply 200 by tangent of 23.6, you're going to get 87.4. All right, so we got this whole thing is 87.4, this whole thing is 56.97, so you're just going to take, running out of space, 87.4 minus 56.97, and you'll get the distance of that tower, or the height of that tower, is roughly 30.4 meters, and that is how I got that answer. Okay. All right, so that's the hardest we're going to get it whenever it comes to trigonometry word problems, guys. All right, so otherwise, hopefully that helped. That was number 15, the challenge. If you got that one, very, very impressive. All right, otherwise, we'll just end it with that. Have a great day, and say hello to Jesus. God bless.